Right, here's just a quick video explaining a couple of questions on this pH-POH worksheet. The first page is mostly just using a formula like that one, or that one, or that one, or that one. So those are the four basic ones, and I think you use similar ones down below. And so that's just basically formula stuff. On the second page, though, there's two questions there where you have to use those formulas too, but you also have to take the information that's given and use it. So in this first question, they're given you a grams or weight, a mass of hydrochloric acid, and they dump it into water. So what you need to determine is what the concentration of that is. To determine concentration, you need moles divided by volume. I have the volume here, but this isn't moles, it's grams. So I need to first use that formula, and so it's 5.3, and divide it by the molar mass of hydrochloric acid, which I calculated over there, and that'll give you the number of moles of hydrochloric acid in the solution. Then you take that and you divide it by the volume, making sure that you put the volume in liters, and this gives you a concentration of hydrochloric acid. In this case here, that is the concentration of hydrochloric acid. When you dissociate hydrochloric acid, it gives you hydrogen ions and chloride ions, and each of those, because the ratios are all 1 to 1 to 1, each of those will have the same concentration as the original one. So the concentration of hydrogen or hydronium ions is that. Now that I know that that's the concentration of these, then I can use my pH formula to figure out what the pH is. And that's the same thing as we did on the page before. So we use the pH negative log of the hydrogen ion concentration, and I come up with a pH of 0.537. They also wanted to know what the hydroxide ion, or the POH was. So you just take 14 minus the pH, and this will be the POH. They also wanted to know what the concentration of hydroxide ions were. So I can use this formula to figure that one out. So it's 10 to the whatever the POH was. And so that gives you the concentration of hydroxide ions. Okay, the next question is a similar one. This time we have a base, barium hydroxide. Same thing though, they give me grams to start with, so I have to use this guy here to figure out how many moles I have. And then I have to use this formula here to figure out what the concentration of that is. Now, when I'm figuring out the concentration, this is the concentration of the whole barium hydroxide. But when you dissociate barium hydroxide in water, if you have 1 mole of barium hydroxide, it gives you 1 mole of barium ions, but it gives you 2 moles of hydroxide ions. So the concentration of hydroxide ions will be double that of the original one. So if the original one was 0.05, etc., then I'd have to times that by 2 to get the concentration of the hydroxide ions. Once I have the concentration of the hydroxide ions, then I can use this formula here to figure out the POH. So the POH is negative log of that, and if you do that, it comes out to 0.998. If they wanted you to know what the pH of that solution was, you just go 14 minus that number, and that'll give you, what, 13.002 or something. That'll give you the pH. And you could find hydronium ion concentrations after too. Alright, hopefully that helps explain sort of what I was doing with those two questions.